Hello everyone. Today I'm going to share you something about question solving in Igcse paper 2. Actually, this is only about the linear motion in a straight line. Yeah. Before we continue our video, don't forget to subscribe my YouTube channel, like, comment, also post the button notification on the subscribe. Okay, thanks for the subscriber, and we will try continue to solve this question. Yeah. Number one, a bus travel at constant speed. It stops for a short time and travel at a higher constant speed. Using the axis in figure 1.1, draw a distance time graph for the bus journey. Okay, actually, because the bus is travel in higher constant speed, so we can say the graphic is straight line up, yeah, with the slope something. The slope is velocity because the velocity is constant, so distance over time it's in the same number. And why start from here? Because the bus stop for a short time. Let's say this is short time. Yeah, let's say we can say maybe around here. This is short time. Yes, this is the best answer for number 1A. Then continue to number B. A lift elevator starts from rest at the ground floor of building. Feature 1.2 is speed time graph for the motion of the lift to the top floor of the building. Yes, we have a graphic about speed in y-axis and time in x-axis. Yeah, and we need to find some question, yeah, about this graph. Let's say, use the graph to determine the distance from the ground floor to the top floor of the building. So, this is actually from the ground floor, and then they have acceleration until around 3.3, here is 3.3 meter second, and then after 3.3 there is constant velocity until the point time at 20 second, and then after 20 second goes down at the deceleration something until 25 second. So we know about the distance as the area of the below of the graph. So we can say the distance here, area, this is equals to area of this trapezium. So on this trapezium we have three shape. This is about triangle, and this is about rectangle, and then this is about triangle again. We split into three shape, so we find one by one. Yeah, this is actually uh, area of trapezium. This is triangle one. Yeah, this is triangle one. A half of 3.3 times 7.4 as the triangle from here to here. Yeah. And then 3.3 times 12.5. This is a rectangle area from here until here. Yeah, the length as time is 12.5, and then triangle of the second one. Yeah, plus triangle as the half of 5. Yeah, 5 as the t, and 3.3 is the height. Yeah, so after we calculate this number, we find the number as the first triangle is 12.375, and that rectangle is 41.25, and the second triangle is 8.25. So we get calculate the number around 61.875. Okay, we continue again about other numbers. Yeah, Don't forget to subscribe my YouTube channel before we continuing. Yes, we have number 2. Figure 1.1 shows the speed time graph for a car traveling along a straight road. The graph shows how the speed of the car changes as the car passes through a small town. Okay, we have about the y-axis as the speed in meter per second, and we have about x-axis as the time, yeah, in second. So if we zoom out here, yeah, like this one, start from constant velocity as 5 25 meter second until the point A, and then go down as the decelerate until point B, and then B constant speed to C. This is actually enters down here, yeah, at the point B, and then after C, this is a lift down here. So B and C, this is in same velocity. Then C and D, this has increase in speed, so have the accelerate, yeah, from C to D, and then after D they constant velocity. So we have some question here. Calculate the distance between the start of the town and the end of the town. So we have enter the town is in point B and leave the town is in point C. So we only find the area between B and C on the below of this line, the below of the graph. So this is actually easy. Yeah? The length of BC equals to 42 minus 18 because this is around 42. Here is 42 and here is 18, yeah, and times with 13. The height or velocity is 30. So we find a 42 minus 18 times 13. So we get 312 meter. Yeah. This is the distance between town, yeah, at point B to point C. So, other question, calculate the acceleration of the car between C and D. Yeah, C and D, they have accelerate. Yeah, start from time when the time is 42 until time D. Yeah, along this is 50, I think 50. Yes. Oh, we already minus this is 12 is the delta t. Yeah? So we can say 31. 31 is velocity when the point D, and 13 is velocity when the point C. Yeah? And divided by interval time taken. So actually we can number here, yeah, 31 minus 13 divided by 12 equals to 1.5 meter second. Okay, this is the acceleration between point C to D when the left down here and then until the D point. So other question is, state how grab so the deceleration of the car has same numerical value at its acceleration. Okay, because slope on AB is same angle or gradient same with the slope BC here. If we see here, this is actually the angle of the acceleration, the angle or differences in speed divided by time. This is same thing here. Yeah, the angle here equals the angle here. So we can say the deceleration here equals to acceleration on here. Yeah, if we see the acceleration at the point CD, the point CD is 1.5 meter second minus 2. So we can say the deceleration at point A to B equals to minus 1.5 meter second minus 2. Yeah, just because the angle of the slope or the gradient of the slope equals. Yeah. Okay. Now other question. Yeah, number 3. But before, don't forget to subscribe my YouTube channel. Please subscribe and watch this video until the end. Yeah. Number 3, figure 1.1 and 1.2 shows speed time graph for two objects. It's moving a straight line. Yeah. We have the speed time is also we have speed, this is time. Describe the motion of the object. So in the graphic 1.1. At the 1.1 we have constant acceleration, yeah, because ratio between speed and time is equally or same in the at the several times. But for question I2, describe the motion of the object shown on the graph in figure 1.2, parabolic speed. Yeah, this is parabolic speed. Yeah, so the graph is actually not in acceleration constant, but the acceleration goes to decrease. Yeah, because if we know this is about the gradient uh, goes to the small, yeah, goes to the small. So we can say the gradient of speed is decreases. And other question B, on a day where on a day with no wind, a large subject dropped from the tall building. The object experiences of air resistance during its fall to the ground. State and explain in terms of the force acting how the acceleration of the object varies during its fall. So the acceleration only by gravitational acceleration actually, yeah, this is constant at 9.81 meter second minus 2. If no wind means the resistance is 0, so we can say this falling the ball only depend by weight. Depend by weight, yeah, that's because mass is constant, gravity also constant, so force is constant, yeah. So if the question in terms force acting, how the acceleration of the object varies during the fall, the acceleration is constant. The acceleration is only about the gravitational acceleration. It's around 9.81 meter second minus 2. Okay, we'll continue again. Number 4. But please to give me subscribe, yeah, and like this video, and also please this comment on this below. uh, Thank you very much for your subscribe. At the point event, champion runner and the car take part in the race. Yes, the runner runs at a constant speed of 10 meters second for the start of the race. Yeah. During the first 5 seconds of the race, the car speed increased from 0 meter per second to 25 meter per second at the uniform rate. On the figure 1.1 draw, the first one, yeah, grab to show the motion of the runner. And the second one, a graph to show the motion of the car. So if we draw it, the runner actually in the constant speed at the 10 meter per second. So we can say the graph is constant at the time until 5 seconds, constant in 10 meter per second. Constant, linear constant, yeah, at the 10 meter per second. And about the motion of the car, because the car starts from 0 and velocity has 25 meter per second at the time 5 seconds, so we can draw the graph start from 0 until 25 meter per second is in here, at the time 5 seconds, so we can say here to here, yeah, the graph like inclined plane. So continue again about other question. B question, use the graph to determine I The distance traveled by runner in 5 seconds. Yes, rather because constant speed, so we can say this is about the distance equal with the area of below the graph. So we can say this is actually only 10 times 5. Yeah, 10 as the speed and 5 at the time. So 10 times 5 equal to 50 meter. Yeah, 50 meter is the distance of the runner until 5 seconds. Okay, continue to question I. Question I2. The distance traveled by the car in 50 seconds. Same thing with the definition of distance. The distance equal to the area of below the graph. So we can say the distance of the car is area of this triangle. So, area of the triangle is a half of 5 times height. Height is 25. So, we can say a half times 5 times 25. We get number 62.5 meter. Yes, this is the distance traveled by a car in 5 seconds. Continue again. Yes, at the time which the effort takes the runner. Yes, this is about 2 meter. Yeah, at 2 seconds. Yeah, because we get the here is 2 seconds. So five. Continue to number five. Yeah. Don't forget to subscribe my YouTube channel. Like, comment, also share to the other. Yeah. I need you to push the button of subscribe. Number five. Yes, we have track and sled. Yeah. Figure 1.1 show the rocket powered sled traveling along a straight track. Yeah. The sled is used to test components before they are sent into space. Wow. In figure 1.1. Uh, Figure 1.2 is speed time graph for the sled from time t 0 second. Well, we have this graph, yeah, and let's see the question. Or the question A, in figure 1.2 mark at the point trouble P to indicate a time when acceleration of the sled is not constant. Yes, I think the it's not constant is here. Yeah, P here until 2 second and little bit something. So after that they have increases in speed, and then they have constant increase in speed, or they have constant acceleration. So the P is in here or on in here. Yeah. Question BI, calculate the acceleration of the sled at the point t equals to 1.0 second. Yes, on the 1 second. So here is 200. Yeah, 240 minus 0 divided by 2, because we use one this triangle, yeah, to find the acceleration of this lead. Okay, we get the 1240 divided by 2 is around 120 meter second minus 2, the acceleration of the sled on the track. Continue again, number II. Determine the distance traveled by sled between 1.0 second to 2.0 second. Yeah, distance is area of trapezium, so we can say here is 240, yeah, minus 120 divided by 2, yeah, or equals to a half of 240 minus 120, and times with distance between 1 to 2. Yeah, this is equal to 1. Yeah, so we can say times 1. Yeah, and we get it is around 60 meter. Okay, the other question, On the final question, I think this one. Don't forget to subscribe my YouTube channel, please. See, the resultant force acting on the sled remains constant during the test. Suggests why the acceleration of the sled is not constant. Yes, because this is about the engine force or driving force here in the same way direction. So actually, this is about sled or this sled actually have engine force or driving force, so the acceleration become increases. Okay, other question 6 here. Thank you very much for your subscribe. Please push the button like, comment, also share. Yes, number 6. A comet traveling in space enters the atmosphere of a planet. Yeah, figure 1.1 is the speed time graph for the comet from the time t equals to 0. Okay, we have some question. Yeah, please see this diagram. Please see the figure 1.1. Yeah, the comet has speed constant at the point here. Yeah, it's around maybe 36, yeah, thousand, and then until around 7 second they goes down with the decelerate, and then constant decelerate, and then after that they come to down in the 12 second. They have like they don't have any speed here. Yeah, they have speed, but in the same time they have uh speed decrease, in the time 12 second. So let's see about the question A. During the period 0 to 6 second, both the speed of the comet and the velocity of the comet remains constant. State what the suggests about the motion of the comet. Yes, because this is same in weight and resistance force on the comet. Yeah, weight and resistance force. The comet is resistant, constant. Yeah, actually, this is about the Newton first law, or total forces equals to 0. Yeah, that velocity, both velocity of or speed, yeah, of the comet remains constant. So, other question, determine the distance traveled during period 0 to 6. Yes, 0 to 6, yeah, just this is about area of the rectangle here. So, distance velocity times time, yeah. Let's say this is 36,000, yeah. This is 36,000 times 6, we get to 116 thousand meter, yeah, or 216 kilometer. Okay, other question, the last question, B, C, and D. uh, don't forget to subscribe my channel, please, and give the comment if any you get any some mistake in here or something else. Explain what the graph shows about the motion of the comet during period 6 seconds to 10 seconds. Yes, they have increases in decelerate and constant decelerate. Yeah, yeah. Between 6 second to 10 second, between 6 second to 6 second actually here and 10 second actually here, they have extreme decelerate. Yeah, extreme decelerate. Yeah, extreme decelerate and goes to the around what to 20,000 meter second. Yeah, about the speed. Yes, and determine the acceleration of the comet at point 11 second. So we can say this is about gradient. Yeah, the gradient 12,000 minus 18,000. Yeah, I use this line. Yeah, this is 12,000 minus 18,000 as the minus. Yeah, divided by 1. Yeah, around 1, because we use rows 11 to 10. Yeah, so we get the number 6,000 meter second minus 2. So high decelerate. Yeah, then suggest what happened to comet at the 10 time 12 second. Yes, in the 12 seconds, so we can say this is actually extreme. Yeah, decelerate. Yeah, s- from in the 12 seconds, so they have decreases velocity from 12,000 until 0. Yeah, so this is I think this is about how if the comet bumping on the earth. Yeah, the comet touched the earth at the point 12 second, and they have 0 velocity. Okay, thank you very much for watching my video. Thank you very much for your subscriber. Please don't forget to like, comment, also share to the others. Yeah, and see in others video what I made it. Thank you very much. Bye bye.